Okay. Moving on to the next topic of matrices. Matrix multiplication. So this is in section A2. It's a kind of long section, but we'll only get started. So we'll only talk about the first 2 pages probably. Or really most of what I'm going to talk about is on this page. So I give some very technical descriptions of stuff here. You don't really have to know it. You pretty much have to know what's right here on this page. So let's actually talk about that. If there's time at the end and there's interest in it, I can talk about what this means. Why is multiplication this weird thing? And why would we do it this way? And what is it supposed to mean? But for now, I just want you guys to know how to calculate it. How do you actually multiply matrices? So this is A2, matrix multiplication. And its consequences. So now, really need to pay attention to detail here. Everything I'm about to say is going to be very important, like the most minute thing. Let A N and B and P E matrices. I want you to notice their dimensions. That's actually very, very important. This is an m by n, that's an n by p. Okay. So there's a matrix with m rows and n columns, and then there's a matrix B with n rows and p columns. We define their product A, B to be equal to C, and here's how C is going to be described. So when you multiply a matrix A, B, where C is the matrix, with entries So the number you're going to put in the ith row and the jth column of C, right? I'm going to tell you how to calculate each position. Okay? It's going to mean you take the ith row of A. And you're going to multiply by the jth column of B, as in a dot product. You're going to take what we call the dot product. It's a special kind of multiplication. And that's how you compute the multiplication of a matrix. Let's just talk about the dot product for a little bit. And I want you to notice that C is going to actually be, we know the size that the result is going to be, where your C is actually going to be an M by P. Okay. Now let's talk a little bit about the dot product. Basically, if you take two things, it could be a row and a column, but you're going to be doing a word multiplication with it. I'm going to write it as a row and a column to be very suggestive. We'll have to have the same number of things in it. So let's say this is A1, A2, all the way up to AN. And this is B1, B2, all the way down to Bn. They have to have the same number of things. Then the dot product is this process. You're going to multiply the corresponding elements, and you're going to add these guys together. So you're going to take A1B1 plus A2B2 plus all the way down to ANBN. Okay, so for example, if I ask you to take the dot product of 1, 2, 3 with 1, 0, minus 7, dot product, that is going to be, multiply the corresponding entries, 1 times 1 plus 2 times 0 plus 3 times minus 7. And that's going to give you, of course, 1 plus 0 minus 21. So this is minus 20 is the answer. So that's what a dot product means. So when I say dot product, the ith row of A with the jth column of B, I want you to do something like this. You're going to take one row and one column, and you're going to multiply them in that fashion. And once you get that number, you're going to put that in the ij position. It's kind of weird when you describe it in words, but we'll practice a few and you'll kind of see what we're talking about. But something I want you to note here. So it's important. And I'll mention some other important things as we move on. So when you're taking A times B equals C, the actual dimensions are important. That's because matrix multiplication is modeling something that happens in multiple dimensions, and you need your dimensions to kind of match up. So here you can have like M by N. This would have to be like N by P. And then this guy is going to be M by P. So there's one thing, before you even start trying to multiply the matrices, there's something that you need to understand. That when you write the matrix multiplication in a certain order, the order is going to matter. Once you stick the two matrices beside each other, this thing has to happen. The two inner numbers must be the same in order for you to multiply. If those are not the same, the multiplication is undefined. So once you line up the matrices from left to right, these two inside numbers must be the same in order to multiply. If they are not the same, you cannot multiply them. Now, the outer numbers also tell you something. When you look at the outer numbers, that tells you the size of the result. So when you're lining up matrices and you want to multiply them, you have to make sure that these things all fall into place. The order is going to matter. Which means, if I were to look at B times A, you could have potentially an issue, right? Because if I look at B times A in this case, then this would be N times P and M by N. And if these are not the same, then the other way can't work, right? So this was how on the calculator, you see, we did A times B, but then when I did B times A, somehow it didn't work. It's because in order for it to work, these numbers must match up. And sometimes when you swap them, they don't match up anymore. And it's funny, even in the case where the numbers will match up when you swap them, you can still get different answers from both of these calculations. So matrix multiplication is not commutative in any sense of the word, right? It's possible to get the same thing by switching, but it happens very rarely. You should not expect it to happen. Once you have matrix, you can multiply them in one order. You switch the order, either you won't be able to multiply, or you might even get a different answer entirely, and that will be very common. So it's important that you know how things line up. The inner numbers will tell you if it's possible to multiply them. The outer numbers are going to tell you how big your answer should be. So if any one of these numbers don't line up, you should know that either what you're trying to do is impossible, or you made a mistake somewhere. That's important. So that's the first thing that's important, how the dimensions of your matrix should line up. The second thing that's important is what I just mentioned. Matrix multiplication is not commutative. Commutative means it's the same if you switch the order, right? Like multiplication of numbers is commutative. Take 2 times 3 is the same as 3 times 2. But in matrices, this is not the case, which means A times B is not the same as B times A in general. In fact, one might exist when the other one doesn't. This is very important. When it comes to matrices, even when you consider that you're doing some sort of algebra on these equations, like we did one earlier where we solve for x, it matters a lot what side you do things on. So if you do something to the right side of one side of the equation, you must do it to the right side of the other side of the equation. The order is going to matter. It matters a lot, right? So matrices, again, the actual calculations you're going to be doing is not hard, but they can be very peculiar with the rules that they will follow. So you can't switch things like you feel like, right? If you multiply by a b on the right side of one side of an equation, you must multiply by b on the right side of the other side of the equation. You can't multiply one side on the right and the other side on the left. It's not correct, right? And you might even get an impossible situation to deal with. So they must line up this way. As a consequence, switching the order does not give you the same thing. In general. So that's something you want to make sure. But another way you can remember what should happen here is in order for this to work, one thing you can just think about is the number of columns in A must be equal to the number of rows in B, where A is representing the guy on the left, and B is representing the guy on the right. Okay? So when it comes to matrix multiplication, order matters, and it's done in this weird way with a dot product, which I'm going to show you some examples, and it means that you can't switch them at will, and if you want to multiply things, the number of columns in the guy on the left must be the same as the number of rows in the guy on the right. Otherwise, the multiplication is undefined. And this is because, well, if we have time, we can talk about it later, but this is because matrix multiplication, like I said, math people tend to think of matrices as functions, and matrix multiplication is really a composition. You want to plug one function into the other. So if the function has an output that doesn't make sense for the input of this function, they can't connect. And the only way they'll make sense is that the input is the input comes from the row, and the output comes from the input comes from the column, and the output comes from the row. And so you need the output of this one to match up to the input of that one, and if it doesn't, they can't connect. So that's something to know. Okay, so those are some things you should be aware of. Let's actually do some equations. Let's put this into practice. But be sure to look out for all these things. So So again, I'm going to give you a bunch of matrices and we're going to try to multiply them in all sorts of arrangements. So let A be 1 minus 1, 2, 1. B is 2, 0, minus 1, 1. C is 1, 2, 3, 0, 2, 4. D is 1, 0, 0, 2, 3, 1. And I want you to find the following. Find A times B. Find B times A. Find A times D. Find D times A. Find C times A. Find C times D. Find D times C. We'll get through this example and then we'll go home. So now you'll know how to add matrices, how to subtract them, how to multiply them, how to find scalar multiplication, and at least you want to appreciate, probably the third thing you want to appreciate, third important thing. Division does not exist for matrices. Right? So if you're trying to solve an equation and you're trying to do something with matrices, the thought that, oh, just divide by this matrix, that's always going to be a wrong thought. It will always be incorrect. It will never be a thing you can do. Division does not exist in this situation. There's something close to it where multiplication by an inverse matrix, right, which is a matrix to the -1 power, but we'll talk about what that means next time. But so far, there's no such thing as division. You can't divide by a matrix, right? So if you take A divided by B, makes no sense. It doesn't make sense to divide A by B. It's just not a way. The way we define multiplication, that thing can't really exist. Okay, so that being said, let's look at A times B.
Is that 0?
So let me do, so that's 1 minus 1, 2, 1, 2, 0, minus 1, 1. Now, first thing you want to think about, is this possible?
Yeah.
Yes, it's possible. This is 2 by 2. This is also a 2 by 2. These are the same. So yeah, we can multiply. We also know that the answer should be a 2 by 2 because that's this one. Right? So I'm going to take a 2 by 2 matrix and I can multiply by a 2 by 2 matrix and the answer should also be a 2 by 2 matrix. Okay. So that we can know ahead of time. Now, how do you actually go about multiplying?
You go by row times column.
Row times column, like what I showed you over here a little bit earlier. So, and again, you know the answer is going to be C, right? Let me just kind of write this up. This is going to be C, right? Where you know we can write it as C11, C12, C21, C22. That's the guys that they would go into position. First row, first column, first row, second column, second row, first column, second row, second column. What these guys mean is you're going to take, for this, you're going to take first row of A dot product with first row of B. Then you're going to take, for this one, you're going to take first row of A dot product, second row of B. Here, you're going to take the second row of A dot product with the first column. First column of B. And here, you're going to take the second row of A, dot product, with the second column of B. That's how you're going to create the answer. So now, let's look at how it would look. So, I'm going to take the first row here, multiply by the first column. First row, first column goes here. So I'm going to take 1 times 2 plus minus 1 times minus 1. So I take this times that, and I take the dot product. So I multiply the corresponding guys and add them together. That would be the first number. For over here, I take the first row times the second column. So that's going to be 1 times 0 plus minus 1 times 1. That ends the first row. So notice to get the first row of the answer, I just use the first row of A. First row times first column here. First row times second column here. Right? If I did the first row times third column, that would go here. First row times the fourth column would go there. Like I can fill out the entire first row by just taking the first row of A and multiplying all the columns. Then once you've exhausted all the columns, you close the matrix and then you move to the next row. So to get the second row of the answer, I'm going to use the second row of A. So I take the second row times the first column, that goes in this position. So it's 2 times 2 plus 1 times minus 1. Then I'm going to take the second row of A times the second column, and 2 times 0 plus 1 times 1. And that is the result. That is the matrix multiplication. I can simplify this. This is 2 plus 1 is 3. This is minus 1. This is 4 minus 1. This is 0 plus 1. That is the answer. That is these two guys multiplied. So again, first row times first column here. First row times second column here. There's no other column, so you move down the row. Second row times first column here. Second row times second column here. And then you simplify and add them together. Another thing I want you to notice that I just did, I was very kind of algorithmic and procedural in how I wrote things down. You'll notice that the second number in the parentheses was always 2. The second number in parentheses was always minus 1. Here, the zeros match with the 0, and 1 match with the 1. I always take the A numbers, I put it in the first place, and I take the B numbers and put it in the second place. I want to make sure I can write out my numbers in a pattern, right? That's very repeatable, right? Because if I made a mistake here, and I need to go back and find it, I need to know exactly where to look for my mistakes. So I know that here, you should sort of see the first, these numbers here, the 2 and the minus 1 is coming from here, 2 and minus 1. And here the 0 and the 1 is here, the 0 and the 1. So you'll notice that the numbers in front, in the first row, are always from A, and they're always the same numbers. And then the numbers in the second one are from the columns of B, and I always write them in the same order. At this point, it doesn't matter what order you're writing things in, but I'd write it in a very specific order and write it that way all the time. So if you ever have to check your work, you'll be able to see when something is out of place. So if you know you made a mistake here, right, and you want to go back and check your work, if you notice that there's like a 3 here, that will stand out to you, right? Because it's not supposed to be a 3, it's supposed to be that, right? So you write it in a certain way all the time. that way your mistakes will kind of stand out to you. Everything will be like, okay, there's a certain pattern to things. So I always write it out a similar way. So that would be A times B. Now let's do it again. Matrix multiplication is something you have to get used to. It's, it doesn't make a lot of intuitive sense, that's for sure. I'm aware of it, everyone's aware of it. It wasn't made to make intuitive sense, it was meant to satisfy a very specific purpose. And it just so turns out when you write down the arithmetic, it doesn't make it obvious how to do it. So you have to follow this procedure, follow it exactly, and kind of make sure you write things in such a way that if you make a mistake, it's easy to catch your mistake. Be very pattern oriented. So B times A would be the opposite. This is 2, 0, minus 1, 1. And A is 1, minus 1, 2, 1. So again, let me run through this one. First row times first column goes into the first position. 2 times 1 plus 0 times 2. First row times second column goes into second position. 2 times minus 1 plus 0 times 1. Second row times first column goes here. Second row times second column goes here. That's the matrix. Now we would simplify. This is 2 plus 0. This is minus 2 plus 0. This is minus 1 plus 2. This is plus 1 plus 1. And so you should get that.
Okay, so the first row goes with the other first column.
Yeah, the columns are controlled by the A, and the rows are controlled by the A, and the columns are controlled by the B. That's how you want to think about it.
So it's.
So if you take the first row of A, that will generate the first row of this. Take the second row of A, that will generate the second row. And the first column, you'll notice that they come from the columns of B. So you know it's always 1, 2, 1, 2. Right? Because we're always looking at the first column here. That's in the first column of B. And then we have minus 1, 1, minus 1, 1. That's from the second column of B. So in the second column, the guys in the parentheses are from the second column of B. So take first row and multiply all the columns, that gives you the first row. Take the second row, multiply all the columns, that gives you the second row. So there's a third row, multiply all the columns, that will give you a third row. Fourth row, multiply all the columns, will give you the fourth row, and so on and so forth. I'd also like you to appreciate that this is not the same answer we got the last time. Which isn't strange. It's actually strange the other way. If you got the same answer, that's strange. Right? So if you multiply things in the different orders and you got the same answer, I'd probably double check your work, you're probably wrong. Because it's very weird to get the same answer when you switch the order. Do another example. There are a lot of examples there, but it's something you have to get used to. Okay. C. How do you do A times D? Huh? So our A is 1 minus 1, 2, 1. Our D is 1, 0, 0, 2, 3, 1. Okay, so how would we do that?
Same way as the other ones.
Yeah, how?
We'll multiply the first row by the first column,
Okay.
the first row by the second column.
What would you get?
Oh, I didn't do what we have.
Okay, so you'll get what?
1.
1 times 1
1 times 1.
plus,
Negative, wait, 0.
okay, then
Wait.
You
go
can't
to the
do
next
that,
one.
can you?
you notice that something is missing, right? You can't do that. This is undefined,
Columns has to equal rows.
right? Now, I don't want you to have to waste your time and start doing stuff and realize that it shouldn't be undefined. This is something you should have noticed from the beginning. If you notice in the beginning, this is a 2 by 2. This one is a 3 by 2.
Oh,
These
yes.
numbers do not match up. It cannot be multiplied. So that one was a trick question. So AD is undefined for these sets of matrices. Okay. What about DA? Switch the order. So if I have 1, 0, 0, 2, 3, 1, multiplied by 1 minus 1, 2, 1, can that work?
Yeah.
Well, you check. This is, what's the size of this one? 3 by 2. This is 2 by 2. These numbers match up. Okay, so this is something that can work. How big is the answer going to be? What is the answer going to look like?
It'll be 52.
The answer is going to be a 3 by 2. Okay, so once you're multiplying matrices, you should know that you can multiply them, and you should know ahead of time how big should the answer be. The answer should be a 3 by 2. So in other words, the answer to this multiplication is going to be the same size as this guy. Okay, now that's going to be equal to. You guys have tried this one on your own. Tell me what you think the answer is.
Just try to picture it.
Give you guys like 30 more seconds.
Think of it as
You got an answer yet? You got an answer? You think you know what it is? What did you get, Tom?
So we're gonna roll with it.
Tell me the row.
Okay, 1 minus 1, 2, 0, 5 minus
We have a guess. Did you get that? You got something different?
No, I didn't finish.
Oh, you didn't finish. Are you starting out like that? Did what you compute so far start to look like this?
My first row was that first.
Okay, that's good. So this is definitely the right size. This is a 3 by 2, so you should have something that's looking like this at least in size. But now the specific numbers, you need to get those as well. Okay, let's see. I don't know what the answer is supposed to be ahead of time. I work it out along with you guys. So, how would it actually be done?
So 1 times 1
Yeah,
plus 0 times 2,
right? First row times first column here, okay?
and then 1 times -1 plus 0 times 1.
First row times second column goes in the second column. Then, okay, what should go here? What should go here?
Nothing?
Nothing.
Is it
You should stop. Okay. It should be a 3 by 2. You already have 2 columns. Stop. Move down. Okay, what goes down here?
2 by 2.
Plus 2 by 2.
Wait, how do you,
2 by, oh, no, no. Yeah, 2 by 1.
0 times second,
0,
2 plus 2 times
wait, how do you get that?
0.
First row times second column. So how should you got that? 0 times -1 plus 2 times 1. Down here, 3 times 1. And then
This one.
3 times -1.
right. So now I'm gonna try to see, does this look kind of like what it should be looking like aesthetically at least? I'll notice, okay, 1, 1, 1, 2, 2, 2, okay, -1, -1, -1, 1, 1, 1. So, okay, those guys seem to match up. And I
Wait,
can
how did you
look
get the
at-
last line? Sorry. The last. what did you
Do every line the same. Row times column. 3 times 1 plus 1 times 2. 3 times -1 plus 1 times 1. And then here I have 1, 0, 1, 0. Okay, that makes sense. 0, 2, 0, 2, 3, 1, 3, 1. Okay, things seem to line up, so I'm gonna continue. And so now we want to actually simplify this. It's gonna kind of squeeze it in here. This is 1 plus 0, 1. -1 plus 0, -1. 0 plus 4. 0 plus 2. 3 plus 2. -3 plus 1. Get it?
Almost.
You made a mistake here. Do you see why you made that mistake? You saw what happened? What happened? Did you actually write this?
I wrote that, but I forgot to multiply.
Oh, but you just didn't multiply? Okay. Want to be careful. Yeah, so again, we're just adding and multiplying. It's not a big deal. It's not, when you're doing it a lot, all at once, you'll forget to multiply something or add something. You have to be careful. But that would be the multiplication here.
Okay, so wait, take a look. It's first row, first column.
Yeah, goes here.
First row, second column.
Goes here.
Then second row, first column.
Here.
Second row, second, okay, I see how it's going here. Alright.
Yeah, so the first row of A creates the first row right here. So first row, first column, first row, second column, first row, third column, first row, fourth column, so on. Then you, once you run out of columns, you move down one more step to the next row.
Okay.
First row, second row, first column, second row, second column, second row, third column. Once you run out of columns,
Yeah.
you move down. Third row, first column, third row, second column, third row, third column, third row, fourth column. You multiply the corresponding numbers and you add them together. Did I miss an E? Oh, I didn't. I did the A times C. E. AC, what is that? Can that even work? I know, these things look like they shouldn't work, right?
They work.
They work. But how do you know?
They work. 'Cause that's
This is a 2 by 2,
and
this
that's
is
2 by 3.
2 by 3. These guys match up, so it definitely works. What is the answer supposed to be? 2 by 3. The answer should be, it has 2 rows and 3 columns, so it's actually the size of the second down here. So you are going to do first row, first column, 1 times 1 plus minus 1 times 0. First row, second column, 1 times 2 plus minus 1 times 2. First row, third column, 1 times 3 plus minus 1 times 4. Ran out of columns, so stop and start on the next row. Second row times first column is going to go here. Second row times second column is going to go here. Second row times third column is going to go here. Second row times first column. Second row times second column. Second row times third column. It says 1 plus 0. 2 minus 2, 3 minus 4, 2 plus 0, 4 plus 2, and 6 plus 4. So that's the answer. Let's do C times A. So C is going to be 1, 2, 3, 0, 2, 4. 1 minus 1, 2, 1. Okay, so what's the first one? Undefined. Alright, so this is a 2 by 3, this is a 2 by 2. These numbers did not match up. So, can't do it. G. What about CD? C is 1, 2, 3. 0, 2, 4. D is 1, 0, 0, 2, 3, 1. Can we do those guys? Well, this is a 2 by 3. This is a 3 by 2. These guys match up, so yeah, the answer should be a 2 by 2. I know the answer should be have this many things in it. Now, first row times first column, 1 times 1 plus 2 times 0 plus 3 times 3. First row times second column, 1 times 0 plus 2 times 2 plus 3 times 1. Second row times first column, 0 times 1 plus 2 times 0 plus 4 times 3. Second row times second column, 0 times 0 plus 2 times 2 plus 4 times 1. Notice that the number in my second parentheses is the same among columns, and it's the same among that. So that'll be that, and this will be simplifying 1 plus 0 plus 9. 0 plus 4 plus 3, 0 plus 0 plus 12, 0 plus 4 plus 4. So that's it. And lastly, DC. Let's do D times C. Let's do it.
You cancel
1, 0, 0, 2, 3, 1. This is 1, 2, 3, 0, 2, 4.
That's 2 by.
Can we? What's the size?
Wait, 3 by 2.
3 by 2, this is
2 by 3.
2 by
Oh,
3.
you can.
These match up, so yeah, we definitely can do it. And the answer is supposed to be a 3 by 3. So this one's gonna have 3 rows, 3 columns.
Could we do this one on our own?
Yep. So here's one where in both orders you can actually do it, but obviously you're not gonna get the same answer because this is a 2 by 2 and this should be a 3 by 3. So try this one.
Oh, yeah.
You should also check later that you can actually do all these in your calculators and you're getting the same numbers. And you got an answer.
So I got 1, 2, 3 for the top row.
1, 2, 3.
0, 4, 8, 3, 13.
I may have messed up some calculation.
You got that? You got exactly the same thing?
Definitely.
You too? Exactly. That's probably right then. I mean, what are the chances that all 3 of you made exactly the same arithmetic mistake? There are a lot of zeros, anything can happen. Let's see. Okay. So for the first position, what did you get?
1, 1
1 times 1.
plus 0 times 0. And then 1 times 2 plus 0 times 2. And 1 times 3 plus 0 times 4. And then the next row.
Okay, so you stop here.
And then 0 times 1 plus 2 times 0. And 0 times 2 plus 2 times 2. 0 times 3 plus 2 times 4. So, 3 times 1 plus 1 times 0. 3 times 2 plus 1 times 2. 3 times 3 plus 1 times 4.
Okay. Yeah, so those seem to line up. Then the rows here seem to line up. So that should be fine. So now we're just going to simplify a little bit. It's 1 plus 0, 2 plus 0, 3 plus 0. So that is actually 1, 2, 3. Here, 0 plus 0, 0 plus 2, 4, 0 plus 8, 3 plus 0, 6 plus 2, and 9 plus 4. So that's the multiplication. We finally got it. Like when you first start, it's like, what the hell is going on? But yeah, you just drill yourself through a few problems, and yeah, you get it eventually. So we will stop there. And I will see you guys next week.